Hi folks, so this is the second part of lesson 7, because what we're going to do in this lesson is we're going to link kinetic energy and gravitational potential energy together, and so we're doing the second bullet point here. So I've done a separate lesson for it. Okay, now at the end of last lesson we did start looking at how energy is moved from one store to another, and I said that if we had a roller coaster at the top here, it would have its maximum gravitational potential energy. When it starts moving, that energy store, gravitational potential energy, becomes less, because it's m times g times h, mass times gravity times height. As the roller coaster comes lower, okay, the height is being reduced, so that m times g times h, that value is going to be smaller, isn't it? The energy store that's increasing is the kinetic energy store, and it's going to be fastest just as the roller coaster hits the bottom down here. Okay, so if we were in a perfect world and there was no losses due to friction, no energy dissipated to the surroundings, then our EP up here would be the same as our EK, kinetic energy, down here. Okay, so in an ideal world then, no losses due to friction. Okay, all right then, so there's a great video for you to watch which explains that, and then I'm going to run through a roller coaster model as well. Okay, all right, so time to pause the video, click onto the link in the original PowerPoint, and you can watch this video here, which is 4 minutes long, and it shows you the linking of the two equations. Okay, off you go. All right, now I am going to show you how to do the same thing using this example here, and you can draw this out, or this sheet might be attached to the lesson so you can access it from there. It tells us that we've got a cart here which has a mass of 500 kilograms, and what it says is, how do we calculate the velocity of the cart when it reaches the bottom of the slope? So these are the steps we're going to go through. Number one, you need to calculate gravitational potential energy at the top here. Okay, let's assume that we're going to use 10 newtons per kilogram for the value of gravitational field strength today. Okay, and then we've got a height of 30 meters. When the cart falls, all you have to remember is that we are going to convert our energy from the store of gravitational potential energy into the store of kinetic energy. Okay, so down here, just as we hit the bottom, our EK is going to be the same as the EP up here. That's the bit that you have to remember. Okay, and then you're going to use the kinetic energy equation. So we're going to substitute that number for kinetic energy into here. We're going to use that equation to calculate the velocity. So here we've written out the velocity equation, which some of you might just prefer to recall, or I'll swap over to my video cam and I'll show you how to rearrange that equation using the Mathsy method. Okay, all right then, so up here we've got our cart and we need to calculate our gravitational potential energy, so it's mass times gravity times height. Okay, so our 500 kilograms times force of gravity 10 times 30 meters gives us 150,000 joules. Now, we said that in a perfect world, our EP energy store, the energy in that store, would swap into our kinetic energy store. So therefore, at the bottom, so assuming no energy losses, which is what these questions do, is going to say, right, well, we'll have 150,000 joules of kinetic energy then, because that's what we had for gravitational potential energy. So now we can substitute that number into this equation, okay, rearranged equation, to get the value of V. Now I'm going to swap to the video cam and I'm going to show you how to do that. Okay, so here we go. So let's assume that let's write the equation out. That's where I always start from. EK equals half times m times v squared and I know my EK is 150,000 joules. It's the same as my gravitational potential energy was at the top. So I'm left with 150,000 times a half times the mass of my cart, which was 500 kilograms, times the velocity squared, and that's what I'm trying to find. I'm trying to isolate that. Okay, so how would I isolate first of all v squared in this equation? Okay, well, I would divide it by a half times 500, so I can get rid of those two. Got to do the same to the other side of the equation. Okay, and now I've got v squared. So how do I get v on its own? I square root the other side of the equation. Okay, so I've got 150,000 divided by a half times 500. Be careful when you put that all into the calculator. Okay, if you're going to put it all in one go, you would need to square root 150,000 divided by brackets your half times 500. Okay, now if you do that, if you work that out, you come out to 24.99, which rounds up to 24.5 meters per second. Okay, all right, let's swap back to the PowerPoint. Okay, the other way of doing it is just to use the equation rearranged already, if you remembered that instead. Okay, so let's drag that away, and oops, and there we've got ending up with the same answer, just popping it in the other way round using that. Okay, so whichever method works for you, best to use the mass equation, but if you're not quite sure how to do that, all right, going back to this, just learning this would be exactly the same. 2 times EK divided by M is exactly the same as EK divided by 0.5 times M. All right, so we end up with the same answer, 24.5. Excellent. Now, time for you to practice. Okay, so there's this applying EP and EK sheet. Have a go at it. I'll go through the answers of one or two of them. Okay, so the first question is, if you accidentally drop a 50p coin, which has got a mass of 0.01 kilograms from the top of the shard, height given as 308 meters this time, how fast will it be travelling when it hits the ground? Okay, so first of all, you have to work out the gravitational potential energy, and then from that substitute that value into the EK equation. Okay, so first job, calculate the EP at the top. So 0.01 is our mass, times 10 times 308 gives us 30.8 joules. EP is converted into EK, we should say a gravitational potential energy store. The energy is moved into the kinetic energy store. So we've got the same value. Okay, and that's the bit that people often forget. Let's just move that out of the way. Okay, and therefore, oops, there's a bit of a pickle there. Okay, rearrange the EK formula. Okay, or go through the Massey method that I just showed you. To get V on its own, we had to square root this number over here, okay, to get 78.5. So we need to square root that number to get our V on its own. Okay, excellent. Right, so the answers are supplied with those sheets. So we'll just move on to the next bit down here. Okay, now this is a question about Alton Tower, the Nemesis, the Alton Towers roller coaster. So this is in relation to question 3, where you had to calculate how fast it would be travelling when it reaches the bottom. Okay, so assuming you've done that question and you've looked at why, it says the top speed is less than what I calculated. So why is this the case? So EP, energy in the EP store goes to energy in the EK store plus the thermal energy dissipated into the surroundings. Okay, so there will be some increases in thermal energy store. So the EK will be less than the maximum that could possibly be calculated. So velocity will be less too. Okay, so you had to have done question 3 to make sense of that one. Now let's look at application in terms of foundation question. Okay, this would be a typical foundation question. You are given a miner of mass 90 kilograms. He's sliding down a slide, okay, and he's got a vertical drop of 15 meters. So could you please work out the change in gravitational potential energy? You are calculating his EP. Off you go. Okay, so worked out your answer there. Mugger 90 times 10 times 15. Show me your calculations. Show me your answer, and the joules, the unit was given there, so 13,500. Excellent. Now a slightly harder version of this would be to say calculate the maximum possible speed that the miner could reach. Okay, so you've got to use your answer to that previous question, okay, to work out the EK here. So calculate the change in gravitational potential energy first, and then you can substitute that number into the EK equation so that you can work out the maximum possible speed. Right, pause the video and we'll let you do that. Notice that here it says gives your answer to an appropriate number of significant figures. Well, that could be anything, couldn't it? So let's have a look. I suppose not, it does say appropriate, and I'd probably go for 2 in that case. Okay, so if you pause the video and had a go. All right then. So our EP, same as before, mass times gravity times height, 13,500. Substitute that then, that's the maximum number it could possibly be, okay, into either this equation or go through the maths method that I showed you earlier in the video. Gives us an answer of 17.32 meters per second, so 2 significant figures there, 17 meters per second. Okay, now here's another exam question. This is a harder one, so have a go at this one. Pause the video and I'll pop the answers up. Okay, so here you go. I'll leave you to work your way through that. If at any point you don't understand anything, this is where, if you've got access to a teacher, ask them. If not, if you're doing this on class charts, then pop an email to your teacher or to me, Mrs. Faint. Okay, so plenary question. Which of these energy changes about an athlete throwing a javelin is incorrect? It's quite a lot to read there, so you'll need to pause the video, have a read of it, and the answer's on the next slide. Okay, so the only one that was incorrect here, picking up the javelin and resting it on your shoulders, because it said here that an energy in the potential energy store was transferred to the kinetic energy stored, and if it's resting, it's not moving, and therefore its kinetic energy store would be 0. Okay, so how far did we get? I think by now, if you had a good go at those calculations, we're looking at working at this level. Excellent. See you next time.